Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal. In this session, we are going to study some of the question bank questions related to cam profiles. And in the previous session, we have studied the axis of the follower is passing through the axis of the camshaft. In this session, we are going to study uniform velocity during ascent and descent, uniform velocity. But here it is, the axis of the follower is not passing through the axis of the shaft. It is passing offset by 5 millimeters. So the type of the follower, here it is knife edge follower, and the maximum lift of the follower is 50 millimeters displacement, and during outstroke, theta outstroke, here it is 120 degrees during outstroke, angle of outstroke, the angle of dwell is 50 degrees next to the outstroke, and the return stroke is 90 degrees, and dwell during the rest of the time, rest of the angle is dwell during return, that is 100 degrees comes, because 360 minus 120 minus 50 minus 90, so it is theta RD, return stroke is 100 degrees. Now the point is that outstroke is 120 degrees, theta OD 50, theta R 90 degrees, theta RD 100 degrees. The lift of the follower is 50 millimeters. So draw the displacement diagram. During ascent and descent, we are considering it is uniform velocity. So on x-axis, take the scale on x-axis, 10 degrees equal to 1 centimeter. Draw the displacement diagram. Divide this x-axis with the angles of theta O, theta OD, theta R, and theta RD. So theta O means 10 degrees equal to 1 centimeter, then theta O becomes 12 centimeters, theta OD 5 centimeters, theta R 9 centimeters, theta RD 10 centimeters. This is theta O is 12 centimeters length, theta OD. Take scale, geometry instruments and draw the straight line, horizontal line. And what about y-axis? The y-axis line is the lift, indicates the lift of the follower. So this is the outstroke and return stroke. Now divide the outstroke and return stroke into even number of parts, equal even number of parts. So the optimum even number of parts are 6. Similarly, return stroke also divide into even number of parts. So mark this even number of parts with the numbers 0, 1, 2, 3, 4, 5, 6. 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash, 0 dash. This is P and Q. So here the motion of the follower is uniform velocity. So it gives a straight line motion. So draw O to P and Q to O dash. Now this curve O, P, Q and O dash is the displacement curve. So when the first 20 degrees, this outstroke is 120 degrees divided into 6 parts, 6 divisions. Each linear division indicates 20 degrees of angle of rotation of the cam. So that 20 degrees of angle of rotation of the cam, first 20 degrees it moves to A, second B, C, D, E, and it is P. At the end of 120 degrees, the follower ascended up to P. What is the length? That is 6 to P distance is 50 millimeters. The maximum distance traveled by the follower is 50 millimeters. Next, theta r, that is 90 degree. 90 degrees is divided return stroke into 6 equal divisional parts. Each part divides, that is how much angle of rotation of the cam, that is 15 degree. For every 15 degree of rotation of the cam, it descends from top sides from this position to here. That is E dash to D dash, next C dash, B dash, A dash, and O dash. In this manner, it descends down. Follower descends down. Is the knife edge notation? It is the knife edge. During ascent, it rises, moves up. It moves up, again it comes down. So there is a period is there, PQ. This PQ is the develop period. So there is neither moving ascending nor descending the follower. That angle of, for a particular angle of rotation of the cam. Here the angle of rotation during the dwell is 50 degree. For a 50 degree rotation of the cam, the follower neither goes up nor comes down. It will be at constant. That's why PQ is the constant. After descending, again rest of the angle of rotation, that is 100 degrees. It is again a dwell. That is the portion here O dash to X. This O dash X is the dwell zone after the return stroke, after the descending of the cam, after descending of the follower. So this rotation, that theta RD, we got it at 100 degrees. At the position theta OD, that is 50 degree. So 150 degrees are going in the dwell zone. There is no motion. But there is here 120, for theta O is 120 degrees and theta R is 90 degree. That is 210 degrees. 200 degrees are under useful condition. So 120 degrees is the maximum time it is going, maximum angle of rotation. For a maximum angle means it takes time. So that's why the time taken for angle of ascent is more than the time taken during descent. Okay. Now this is the displacement diagram. Now next is that we have to draw the cam profile by using this displacement diagram. Or in other words, displacement diagram is the prerequisite for drawing the cam profile. Now let us begin with the base circle. First step is base circle. The radius of the base circle is 30 millimeters. Okay. Now this is the axis. The axis of the follower, here it is not passing through the axis of the camshaft. How much it is? Next, draw the offset circle. Offset by how much? Offset by 5 millimeters. So draw 5 millimeters radius circle. Now by touching the tangential surface of the offset circle intersecting the base circle at the top, at the circumference, this is the point. The roller is contact. So join this base circle center to tracing point. This is the reference line to mark the displacement of outstroke theta O, theta OD, theta R, theta RD. The theta O is angular displacement is 120 degrees. Next it is 20. Next 50. Next 100. Remaining thing is theta RD. This is theta O. This is theta OD. This is theta R, and it is the portion theta RD. Now very important is that divide the circumference of the base circle into 6 parts, six angular displacement, 6 equal divisions. Now this is 1, 2, 3, 4, 5, 6. Similarly, theta return, that return stroke also divide. This is 6 dash, it is 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. Very important here it is. In 0 offset, we have drawn radial lines from the center of the base circle passing through the divided points, angular displacement points. Now, we have to draw here tangential lines because the contact axis of the follower is tangential to the offset circle. So all these lines should pass through the tangential to the offset circle, passing through these divisions. Now, those are the lines or the reference lines in order to mark the displacement position of the follower for a particular angle of rotation of a cam. Okay, now passing through this, similarly it should pass through. The next one, like that, return stroke also. So these are the lines. On these lines you have to mark the tracing points of the follower for a particular rotation. So how to take this radial distance from the displacement diagram? 1 to A, mark it, this is the A. Next 2 to B, next 3 to C, 4 to D. From where it came from? 4 to, this is the fourth and it is the D, 4 to D. Next 5 to E. 6, this is the line, 6 to tangential line, this is 6 to P. Next 6 dash to Q distance, 6 dash to Q, 5 dash to E dash, 4 dash to D dash, 3 dash to C dash, 2 dash to B dash, 1 dash to A dash and finally here. Now join all these points with a smooth curve. That curve represents the profile of a cam for a particular rotation. Angle of ascent, angle of descent and angle of dwell. Now join this curve. This curve is the profile of a cam. So in this manner we have to answer the question for a case of offset circle. Okay. Next problem. Here the follower is, for the same notations, is a 50 millimeters. Linear displacement is 50 millimeters and offset is 5 millimeters. And during ascent and descent, it is UV, uniform velocity motion. So the axis of the follower, but here only one difference is that it is oscillating knife edge follower outwards through. It should be here, we are going to consider the follower is roller follower. Consider the roller follower radius. Consider the roller follower radius equal to 10 millimeter. So it's very important case study. For this, the uniform velocity during ascent and descent, theta O outstroke or ascending angle is 120 degrees Next to ascending, it is the 50 degree, and return stroke or the angle of descent is 90 degrees, and remaining is the dwell during return or ascending, that is 100 degrees. So it is the same displacement. Now we are considering drawing using the roller follower. Okay, let us begin. First, the minimum radius of the cam considered here, it is 30 millimeters. If we assume it, if it is not given, if it is given, okay, if it is not given, assume any 30 millimeters, 25 millimeters according to your convenience, but you have to mention that assumption. That assumption is 30 millimeters. Now, draw the minimum radius of the cam, that is 30 millimeters. Okay, next, this is the center of the base circle. We know that already offset by 5 millimeters. This is 5 millimeters offset circle. Touching the surface, draw a line. This is the offset axis line, offset. This is the point. From this distance, take 10 millimeters length and draw a circle. That is the roller circle. Now join the center of base circle to the center of the follower, center of the roller. That is the tracing point. This O and O1 is the reference axis. Passing through the O1, draw a circle. That is the prime circle. We have to draw the prime circle. Use geometry instruments. Okay. Divide this prime circle into equal number of, this is the reference axis now. This 120 degrees, 50, 90, and again remaining. This portion is theta O. This is theta OD, and it is theta R, and it is theta RD. Now, after dividing this, we have to divide the prime circle circumference with even number of parts. What are they? So divide into equal, that is 120 by 6, even number of, there is 6 number of division, that is each division takes the 20 degrees. Now, these are the divisions 0, 1, 2, 3, 4, 5 and 6. Similarly, this is 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. Now it is the case study of offset circle. Now here it is, the axis of the follower is offset by 5 millimeters. That offset by means it is touching tangential to the offset circle, the axis of the follower. Now wherever tracing points are there passing through that, it should be offset by. Further, what to do in order to get the offset lines, we have to draw a tangential lines passing through the divisioned points marks. Now 1 dash, 1 should pass through the tangential line to the offset circle. So 3. Six. Similarly, so these lines should pass through it. So on these tangential lines, it is the position of path of, it is the locus of the roller during offset. So on these lines, tangential lines will mark the displacement. That displacement point gives the center of the roller. So we have to take a distance from 1 to A, 2 to B, 3 to C, 4 to D and mark on these tangential lines. This is A, it is B, 3 to C, 4 to D, 5 to E, 6 to P, 6 dash to Q, 5 dash to again E dash, 4 dash 2. These are the distance came from displacement diagram. That is D dash, C dash, B dash, that is A dash. These are the centers of roller. This A is the center of the roller, B is the center of the roller, C. So through all these centers, draw a circle. It should touch the surface. Now, if you draw the surfaces of all rollers, the curve represents the profile of a cam. Now, it is the smooth curve. Draw a smooth curve. Okay. Here this roller has to touch. Okay. In this manner it comes. If you use geometry instruments. I am only giving the procedure how to draw the cam profiles. This is the profile of a cam. Profile. So there are various circles are here. There are 4 circles are observed in this problem. Number 1 is the smallest circle. Here it is the offset circle, roller circle, and base circle and prime circle. So prime circle is different from the base circle. In the case of roller followers, the prime circle is different from the base circle. Whereas in the case of knife edge follower, the prime circle is same as base circle. Now, prime circle, the radius of the prime circle is equal to the radius of the base circle plus radius of the roller. That means the prime circle and base circle are differentiated by the roller radius. That is, here it is 10 millimeters. Now, why we have to draw all these surfaces contacting of the roller? Because here, when the roller is in contact with the cam, the contact with the cam is the surface or the touching, the point, the contact, okay, circumference, the circle, the cam profile, the circle will touch the surface. It's not the center will touch. So there is no knife edge. In the case of knife edge follower, is the contact point is the tracing point, whereas in this case of roller follower, the center of the roller is the tracing point. That tracing point helps to draw the cam profiles. So tracing point of the roller is so important in order to draw the profile of a cam. And one more important is that there is an angle between the motion of the follower to normal to the pitch curve, normal line to the pitch curve. That angle is known as pressure angle. If the pressure angle is maximum, then jamming takes place. Jamming of the roller takes place in its bearings. In order to avoid the jamming, what to do? We have to consider the optimum value of the pressure angle. Alright. Now here, for drawing the cam profile, base circle is required, offset circle, in the case of offset circle, and radius of the roller, and prime circle. And these are the parameters are highly important. And one more important parameter is angle of rotations. That means angle of ascent. What is the angle of ascent? what is the dwell, and what is the angle of dwell, what is the angle of return, angle of dwell during return. And one more important is that lift of the follower. So lift of the follower is dependent upon the angle of rotation of the cam. The maximum lift of the follower during ascent should be same during descent. So during ascent, here it is 120 degree, and during descent the angle of rotation, that angle of return, is 90 degrees. So but the lift of the follower during ascent is 50 millimeters. It comes back again 50 millimeters in return. So here for 120 degrees of cam rotation, the 50 millimeters moving. Similarly for 90 degrees of cam rotation, it is 50 millimeters returns back. That means the time taking during ascent is more in comparison to the time taking during descent. That means time taking during descent is low in comparison to the time taking during ascent, because theta O is more than theta R. Angle of ascent during ascending outstroke angle is more than the return stroke angle. So next, these are the problems. Coming to the definitions, some other definitions. What is explain the angle of action? What is the action? Angle of action means the angle at which ascending of follower takes place. That is the angle of action. So it is the angle of ascend. Action takes means rising of the follower takes place. That is the angle of action. Now here, what is understanding? It is comes under the question of Bloom's taxonomy. Understanding. The course outcome is 4, CO4. It is related to the profiles, cam profiles. Now, explain with the help of displacement diagrams the UARM. What is the meaning of UARM? It is a short form of uniform acceleration and retardation. Uniform acceleration and retardation. That is UARM. Uniform acceleration and retardation. Motion. Finally, M for motion. So these are the terms used for the follower motion. So what is the displacement diagram for uniform acceleration and retardation? The uniform acceleration retardation, the displacement diagram, I am considering only first suppose theta O. If you consider theta O equal to 120 degrees, consider. Divide this 120 degrees in the scale, that is 20 degree equal to 1 centimeter. That becomes the length of this outstroke portion is 6 centimeters. Divide into 6 number of parts. Mark it 0, 1, 2, 3, 4, 5, 6. That is UARM, uniform acceleration and retardation motion. So during ascent, I am considering. Descent also you have to follow same thing. Divide this center line of the portion into same 6 number of divisions. That is 0 here starting 1, 2, 3, 4, 5. Yes. And it is finally 6. And consider this point P. Join O from this corner to 1 and O to 2 and O to 3. Similarly, P to 3, P4, P5. Already P6 is joined horizontally. Now when 1 is intersecting here, this inclined line, 2 with the 2, 3 here, 4, 5 and 6. Join the passing through this curve. That curve is the curve traced during displacement curve of uniform acceleration motion during ascent. This is the displacement during ascent. Similarly, you follow same procedure for the return stroke portion or return stroke angle. That curve, that is the parabola. Okay. This is the curve. That is called uniform acceleration curve for displacement curve of uniform acceleration retardation motion. This retardation takes place when it is descending. So that is the explanation for this. Explain cam. Cam is nothing but a circular or oval shaped disc for controlling the valves in internal combustion engines. So how many cams are required for each valve? Only one cam is required for controlling each valve. So there are two cams are required on camshaft for controlling two valves. Now explain the use of cams and followers. Yes, without seeing this question I answered. Now explain the use of cams and followers. These cams and followers are highly important in internal combustion engines for controlling the valves. These valves are highly important in order to supply the fuel and exhaust gases during exhaust stroke. There are 4 strokes are there for 4-stroke engine. First, number 1, suction stroke. Second stroke is the compression. Third one is expansion. Fourth one is exhaust. So under these 4 strokes, the complete IC engine functions. When 4 strokes completes, it is known as one cycle. So these 4 strokes, here it is so important. It is like a human body. We will discuss more how the internal combustion engine, complete automobile engine is related to human body. So if any body in human body, if heart doesn't function, that body is useless. Similarly, if engine doesn't work out, that vehicle is useless. So that's why the cost of the engine is very high level compared as heart is very costly in replacing the heart surgery during heart surgery. So we'll discuss more. But here, explain a tangent cam. So we'll discuss in second portion. There are different types of circular arc cams and tangential cams. So in simply, if you want to discuss this tangent cams, the surface of that is called flank. The flank looks like a tangential to the base, to the circle, small and larger circles. This portion will discuss in synthesis of the cams. Now it is coming to next question. Next level we'll study. Now explain follower. Follower is nothing but a valve which operates, helps to opening and closing, allowing the fuel into the engine and also sending the exhaust gases outside. And there are various types of followers are there. Yes, one more question is that classify the follower types. So various types of followers, that is we studied in the sessions only 3 types of followers. If the knife edge follower, based on the shape, it is a knife edge follower. And if it is the roller in touch with the shaft, that is a roller follower. If it is a flat face, then it's called flat face follower. Like human beings, based on the color, there are different classifications. In US, if it goes there is a black and whites. In India, there are different categories. Now here, what is explain the angle of dwell in cams? So it is the angle of portion, particular angle of displacement in the cam, where when the follower in contact with that portion, the follower doesn't have neither ascent nor descent, or neither rising nor falling down. So that angle displacement on the cam is known as the dwell. Dwelling means is staying there only. That is the dictionary meaning. So dwelling means no motion. Is always dwelling in the house. Doesn't do anything. If the motion is there, similarly, the follower, when it is in contact, that angular portion of the cam, it doesn't move neither ascent portion nor descending. It remains same for that particular angle of dwell. That is known as angle of dwell, particular angle. Explain pressure angle in cams. Pressure angle is so important. First, definition of the pressure angle is that it is the angle between the direction of the follower to the maximum normal to the pitch curve. So here, this pressure angle highly useful in designing the cams. When pressure angle is high, the follower jumps in its bearings. So pressure angle is very important in designing the cams. And we'll study this pressure angle in gear trains also. Now, what is the angle of ascent? This angle of ascent is nothing but at that angle of rotation of the cam, the follower moves up, ascending takes place. That angle is known as angle of ascending. So related to that, another question is what is meant by angle of descent? Not this question. Explain meant by no. Explain What is angle of, explain angle of ascent. What is the angle of descent? The angle of rotation of the cam, for a particular angle of rotation of the cam, the descending motion of the follower takes place. That angle of rotation of the cam is known as angle of descent. Next, application of the cams already discussed. This is angle of action, discussed already. Dwell also discussed, but different angle of explained dwell. Here not angle of dwell, it is explained dwell only. So we can understand that this dwelling means it is related to the follower. The follower doesn't move, neither ascend nor descend. That is angle of dwell. Next, explain the classification of followers according to the path of motion. Yes, according to the path of motion, explain the classification of the follower according to the path of motion. So here, if it is uniform velocity, if the followers are having a motion of uniform velocity, then uniform velocity follower, provided if the shape of the follower is knife edge, then it is uniform velocity knife edged follower. And uniform, and there are three types of motions which studied here. That is uniform velocity, simple harmonic, and also UARM, uniform acceleration and retarded motion. So there are different types of follower: knife edge follower, roller follower, and flat phased followers. Next, explain the motion of follower. There are various types of motions of the follower, that is uniform velocity motion, simple harmonic motion, and uniform acceleration and retardation motion. So those are in forms UV, SHM, UARM. UVM means uniform velocity motion, SHM simple harmonic motion, UARM uniform acceleration and retardation motion. These are the three motions of the followers. There is another motion is called cycloidal motion. Okay, next, explain the necessary elements of a cam mechanism. The necessary elements is of a cam mechanism is one is cam, another one is follower. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.